everybody, and thank you for joining. We're going to go over in the next hour around Tanzu standard and basically Tanzu Run. How do we incorporate Kubernetes inside vSphere itself? I'm Owen Pencil. I'm a technical leader for emerging technologies in the Modern Application Platforms business unit in VMware. And the MAP BU, as we call that, is the BU that is responsible for the modernization of the application. And it's basically an integration between several companies that we've acquired, Heptio, Pivotal, and Bitnami. The reason I'm saying that is because all of those companies were heavily investing in the open source community in different aspects. So Heptio more in the cloud native computing foundation, Pivotal with the cloud foundry, and Bitnami all over. And those three companies is basically aggregated into the Tanzu portfolio. Now, the first thing is going over the Tanzu portfolio in general. The Tanzu portfolio is divided into three main pillars: the build, the run, and the manage. And it's the entire solution or the entire portfolio of Tanzu allows you to utilize or leverage Kubernetes as an API layer to do everything inside that supply chain of the application. So to build your application, to push that into production, to create pipelines and orchestrations, to consume open source projects, and then of course run that application on Kubernetes across any infrastructure provider, not just vSphere, and I will get to that in the presentation. And then when you have all of those different Kubernetes clusters on-premise or off-premise, you need to have that consistency to manage everything under the same stack or the same tools and dashboard, and that's the Tanzu manage pillar. And we will go over that as well today. I want to say before I'm starting that if you have any questions, please just put it on the chat or the Q&A, and I will stop and answer the questions as they come. And I won't get into too much depth in the Kubernetes side, not just because there's a lot of beginner level in the conversation, because what we are aiming to do inside Tanzu is to make Kubernetes as easy as electricity, make Kubernetes as easy as provision a VM. And you will see that with vSphere with Tanzu services. So by incorporating Kubernetes inside vSphere, we are allowing our VI admins and infrastructure personnel basically to provision Kubernetes clusters and to expose Kubernetes services directly from the vCenter in their own tool sets and with their own skill sets. Okay, so let's start. So the Tanzu Run, that's the base foundation layer of the Tanzu portfolio, is divided into two different layers, or two different consumers, or two different solutions. And the first one, or the bottom line, is the foundation itself. And the foundation is Cloud Foundation, vSphere with Tanzu. There's a lot of different ways to consume that foundation, but that's basically Kubernetes services inside vSphere. That's enabling Kubernetes as part of your vSphere cluster. And we will get to that and the different capabilities that you can leverage with that. That's the foundation. That foundation is more aimed to answer the challenges of the VI admins and basically use the same tool sets and skill set to manage Kubernetes as part of the vSphere environment. Now, there's a different layer or additional layer, an abstracted layer of Tanzu Kubernetes Grid. And Tanzu Kubernetes Grid is Kubernetes clusters built in VMs. So if you have vSphere as the foundation, running Kubernetes in the foundation, now you can run Kubernetes clusters on top of that foundation based on virtual machines, just like you're creating any other Kubernetes distribution clusters. So if you're using EKS or AKS in Azure or GKE on Google or OpenShift on premise, they will run on vSphere or any other way as virtual machines. And that's Tanzu Kubernetes Grid. The value of Tanzu Kubernetes Grid is it's abstracted across any infrastructure provider. So it's more aimed to answer the challenges or the demands of the development or the DevOps engineer side of the coin. Basically, those DevOps engineers and developers wants to get the consistency of the same API layer across any infrastructure provider. So interact with Kubernetes exactly the same way across vSphere, AWS, GCP, and others. And maybe transition the application or the workload or expand or resize or do a lot of other things. But to do that, they have to get that consistency. They have to get that Kubernetes API you can see on the left side that is exactly the same across any infrastructure provider. The only way to achieve that is by aligning with the open source communities, by aligning with the Tanzu, with the Kubernetes project itself. And we are doing that in VMware for the last 2 years, contributing to Kubernetes and more than pretty much any other company. We are the second largest contributor to Kubernetes as a project. And there's a lot of different open source tool sets and projects that I will mention in the presentation that we are actively contributing to. Without that contribution, we couldn't give our customers the support they need to run those tool sets and projects in production. So that's why we are heavily supporting and contributing to the open source community in the Cloud Native Computing Foundation. So we are starting with the foundation. The foundation is built around vSphere. And when I'm saying build around vSphere, it's actually integrated inside vSphere itself. When you enable Kubernetes services inside a vCenter cluster, each and every one of your ESXi nodes will become a Kubernetes node, a Kubernetes worker. And that means you can actually spin up or schedule workloads directly on those ESXis. And now that ESXi that works as a Kubernetes node and runs Kubernetes structures is basically like running Kubernetes workloads directly on bare metal, because the OS itself is the ESXi. Now, the ESXi has been evolving for the last 20 years in making better calls to CPU and memory and basically manage that consumption of the physical layer. So that will bring you a lot of value on the performance side of anything that will run on the Kubernetes directly on that ESXi. Kubernetes in general is divided into 2 layers, the control plane and the worker nodes. So the worker nodes, as I said, is going to be the ESXis themselves. Those will be the nodes that the workloads will be scheduled on. The control plane is built out of 3 VMs that basically form that control plane of Kubernetes. And that Kubernetes cluster is upstream, aligned with the community. We didn't fault Kubernetes or change Kubernetes. It's exactly the same Kubernetes you will get from anything else, but it's installed directly on ESXi. Those 3 VMs that will be created as part of the enablement of the Kubernetes services will expose an API endpoint. That API endpoint is kube control API or Kubernetes API. Again, upstream directly from the community. Now, that kube control API now allows me to work and interact with that vSphere cluster or vCenter cluster in a Kubernetes kind of way. I can declare objects, I can create manifest built on YAML files, and I can deploy them directly on my vSphere Kubernetes cluster. Just for terminology perspective, the Kubernetes services inside vSphere, we call that a supervisor cluster, like hypervisor for VMs, supervisor for Kubernetes. So that supervisor cluster is now, I can now deploy Kubernetes constructs and objects directly on that supervisor cluster, and that supervisor cluster will schedule that on ESXi hosts. I can see there's a question. I have a request. I'm trying to deploy TKG in AWS. Okay, so specific TKG in AWS questions, I can refer to that after the session or in the end of the session. If there's anything about specific that point of session, you can stop me again and ask the question or just post that in the chat or Q&A. So you can see a lot of different objects running on that vSphere environment. You can see vSphere pods, what we call a native pod. Those are just Kubernetes pods running directly on ESXi. You can spin up virtual machines, and that's something that we've developed as part of the vSphere environment, vSphere 7, and that's the enable you to declare in a manifest a virtual machine and then use Kubernetes to provision that VM and basically control that VM along the time, so reconcile that VM if something goes wrong. Now you can also see a Kubernetes cluster structure. That Kubernetes cluster is basically a Tanzu Kubernetes grid cluster. I've said there's 2 layers, right? There's the foundation, and then there's the Tanzu Kubernetes grid cluster. The Tanzu Kubernetes grid cluster is built out of VMs, and all the different plumbing to infrastructure that Kubernetes cluster needs is being supported and it's being exposed by the foundation itself. Exactly like any other cloud service Kubernetes services, like EKS in Amazon, AKS in Azure, GKE in Google, inside the vSphere environment, that TKG cluster needs network, it needs a storage, and it needs compute. In Kubernetes, those three plugins or those three pillars is CPI, Cloud Provider Interface, that's for compute, CNI, Cloud Network Interface, that's for networking, and CSI, Cloud Storage Interface, and that's for storage. Those three pillars or those three plumbing from the Tanzu Kubernetes grid down and in the foundation itself is being answered with vSphere. So the CPI is vSphere itself. The CSI, the storage interface, is again vSphere itself with a component called Cloud Native Storage. And that Cloud Native Storage is part of vSphere. It's supporting any data store that you have, not just vSun, and it's enabled from vSphere 6.7 update 3. So that's the first version where you can actually provision clusters with Tanzu Kubernetes grid, but it's not vSphere 7 and it's not running supervisor cluster. There's a difference between the two, and I will get to that. So CSI, vSphere, CPI, vSphere, what's the networking interface? The cloud network interface for that vSphere environment is NSX. NSX is the only programmable network that can be a CNI for that environment in the supervisor cluster that will support a native pod, running pods directly on the vSphere environment. The reason for that is NSX is managing layer 2, 3, 4, 7, and security, so distributed firewall rules and others. And that's the only CNI that is supported as part of the E6I as nodes. I will get to the difference between the two, but it's important to understand that the foundation of the vSphere with Tanzu cluster, to be able to run workloads directly on that, you will need NSX as the cloud network interface. Okay, so let's go to the second layer, and that's the Tanzu Kubernetes grid. Before that, in that aspect of the supervisor cluster, when you're declaring an object in Kubernetes, you do that with a YAML file, with a declaration file. What we are achieving now with that common ground of the Kubernetes layer is basically to declare or to create manifests of different objects, not just Kubernetes, but now also VM, database, and function as a service if you're using that. By getting the common ground between all of the different objects and addressing everything as Kubernetes objects, now we can aggregate those into containers or aggregate those into namespaces. Namespaces in Kubernetes is logical boundary where you have a shared user space, a shared storage space, and a shared permission space. And in the vSphere side, if you're creating that namespace on a supervisor cluster, on the vSphere side, that namespace will be represented as a resource pool. Because it's a resource pool on your vSphere environment, you can now apply policies. You can apply quota policies, permissions policies, storage policies, and others. And that will allow you as a VI admin to basically create a playground for your developers or DevOps engineers, guardrail that playground with different policies, and then expose a kube control API endpoint with the permissions to that namespace for your DevOps engineers. And from their end, it doesn't really matter if it's a person or it's a pipeline or it's orchestration or automation process. From the other end, that namespace is just an upstream Kubernetes endpoint. And when you provision objects in that namespace, you basically provision objects according to the limitation you have in the policy underneath. So that will allow you to, just think about the first image of those two different components, the VI admins with the foundation and the DevOps engineers or anything else in the Tanzu Kubernetes grid. That will allow the VI admin to play with the same tools and understand the same construct he knows right now. But from the other end, expose a kube control API that is upstream and aligned with the community and to the DevOps engineer to basically keep going and create the workloads and structures that he needs. So that's the supervisor cluster. Okay, let's talk about the difference a bit. So I've said that when you enable that Kubernetes cluster inside the vSphere, that's creating the supervisor cluster. From one hand, you will have the E6I as the nodes. You can see that on the left side. And from the other end, you will have on the right side, 3 different control planes based on VMs. You can see a virtual IP. That virtual IP will be the API endpoint for Kubernetes to interact with. So when your developers or VI admins will interact with the cluster, with kube control API, they will do that against the virtual IP of that control plane. Now, once I'm getting another layer up, I'm creating those objects. One of the objects can be that Tanzu Kubernetes grid you can see here. And Tanzu Kubernetes grid will also have control plane and worker, the same structure of Kubernetes. And it will also have the virtual IP to interact with kube control with that cluster. Those are the two layers of the Tanzu run. You have the foundation and you have the Tanzu Kubernetes grid cluster. Now, let's get into details around how do you provision applications or the clusters themselves. So when I'm provisioning a cluster on the supervisor cluster, I'm basically saying to the cluster, to the supervisor cluster, I want a different cluster. I want a guest cluster built on VMs. I want a Tanzu Kubernetes grid cluster. I want it to be formed from one control plane and one worker, and that will provision me that green cluster that you see up in the slide. Now that cluster is again open source led, and the solution around Tanzu Kubernetes grid is more open source structured to get that consistency. It's exactly the same Kubernetes cluster that you can run on EC2s on AWS or Azure servers on Azure Cloud. So you can see the networking stack is not NSX. You can see the networking stack is either Andrea, and that's the default cloud network interface for that cluster. But if you want to change that and use Calico instead, you can use Calico instead. That's another common CNI for Kubernetes. The storage parts or the CPI and CSI for that cluster will be again vSphere. So when someone will try to consume persistent storage or something else from that cluster, it will basically interact with vSphere and vCenter, and vSphere and vCenter, the foundation, the supervisor cluster, will support the request and assign any resource that it needs. Now, in vSphere 7 update 1, we have another option. And the second option we have in vSphere 7 update 1 is to run that same orchestration without NSX. But if we are eliminating NSX, we are eliminating the capability of running native pods. It doesn't mean that we can't create VMs or Kubernetes clusters. It just means that we can't run native pods. We can't run workloads directly on that. And we are replacing NSX with AJ proxy to create that load balancing, because the virtual machines will still need some kind of AJ or a load balancer basically to create that AJ between the virtual machines. And the Tanzu Kubernetes grid cluster will also need something to assign a load balancer IP. And if I'm applying any application on that Tanzu Kubernetes grid cluster, again, I need something to assign an IP to me to basically browse the application. That orchestration in vSphere 7 update 1 happens in the AJ proxy. Now, it's not just that you can't run native pods. The entire structure of the node in ESXi is being eliminated. So basically, those ESXi nodes will not be in a supervisor cluster that doesn't have NSX. I will show you in the demo two different environments, one with NSX and one without NSX. When I will just check the structure of the cluster with NSX, I will see the ESXi as the nodes, and I will see 3 VMs as the control planes. Without NSX, I will only see control planes. I won't see any nodes. And the reason for that is I don't have any CNI, cloud network interface for that cluster. I'm just using AJ proxy to create additional clusters. So that's the difference between the two. And that's also the difference between different packaging and licensing for that Tanzu portfolio aspects. There's a question. AJ proxy will be used for control plane as well as apps load balancing. Definitely yes, yes. So AJ proxy is taking ownership on the load balancing aspect of that environment for the control planes and for applications as well. So that Tanzu Kubernetes grid, I've said that basically Tanzu Kubernetes grid is the second layer. It's an abstraction of like any infrastructure provider. The way that we are doing that is with Cluster API. Cluster API is the lifecycle management engine from the Cloud Native Computing Foundation. That's the general lifecycle management engine from the community. And it's being absorbed as the standard de facto of lifecycle management for Kubernetes. The latest announcement around Cluster API was Amazon EKS. So EKS is also using Cluster API to manage their own clusters. The control planes in EKS will be managed by cluster API. We are leveraging that mechanism, that cluster API mechanism, to basically abstract between different infrastructure providers. So cluster API has different subsets to different clouds. So the way that cluster API is interacting with vSphere is not the same as it's interacting with AWS or with Azure or with GCP. But the way that you're interacting with cluster API is by kubectl API. So we are basically leveraging Kubernetes to create and manage Kubernetes clusters. And that's like an inception mode. So basically we are using Kubernetes as a platform to run platforms and not just as a platform to run workloads. If you ask Joe Beda or Craig McLuckie, the founders of Kubernetes, 2 out of 3 founders of Kubernetes that actually works in VMware and leading that strategy ahead. If you ask them what is Kubernetes, they will say that's the answer. Kubernetes is a platform to run and manage platforms. And you can extend that platform of Kubernetes to introduce new objects with CRDs, custom resource definitions, basically saying to Kubernetes, you know what, that's a new object, that's a cluster, now manage that cluster. The cluster will be formed from one control plane, one worker, and now make sure that it's always going to run with that configuration, with that declaration, or with that manifest. And that's what we're going to do in our demo as well. Now, each and every one of those pillars is basically a region, right? So if you have a vCenter in your environment, a vCenter is a single region. And Tanzu Kubernetes Grid with the Tanzu services on vSphere will allow you to manage and lifecycle manage those clusters in a single region. Then if you want to go to AWS, you will have another region on AWS and so on and so forth, according to the infrastructure provider that you will use. Now, we still need something to manage everything. And we need like an abstraction layer for that abstraction layer, something that will allow us to multi-region manage everything, all the fleet of clusters that we have. And that's Tanzu Mission Control. I will get to that in further down the presentation, and we will see that in the demo. But it's important to understand the layers. So we have Kubernetes as the foundation, then we have Tanzu Kubernetes Grid running on that foundation, and then we have Tanzu Mission Control to manage different Tanzu Kubernetes Grid regions. And Tanzu Mission Control will also allow you to provision cluster and manage them across vSphere, AWS, and Azure from a single dashboard and a single service. And I will get to that again in the demo. Another question. Do we support Avi for load balancing solution today? Okay, so Avi is definitely a solution that will be getting in the portfolio. It's not supported right now, but it's the next version that Avi will be supported. Avi also gonna have different flavors or different licensing packages. So stay tuned. There's going to be a lot of announcement around Avi Networks or NSX Advanced Load Balancer in the Kubernetes landscape moving forward shortly. So in the next couple of weeks, months. Okay, so I'm getting back into Cluster API. And Cluster API, as I said, is built on Kubernetes. So it needs Kubernetes to run Kubernetes. We are declaring a Kubernetes manifest file. And in that Kubernetes manifest file, we are saying, how do we want our cluster to be formed? So that management control point or that management cluster, the first Tanzu Kubernetes Grid management cluster, can be either the Tanzu in vSphere, that's a supervisor cluster, that's an ideal management point. But in AWS, you don't have supervisor cluster. So there, it's going to be installed in a single node Kubernetes cluster that will actually be the management for that region. And from that management control point, you can now create different Kubernetes clusters with different desired states on different infrastructure providers. But you can do that in a consistent way with the same tool sets, mechanisms, and basically the same way of interacting with things. So Tanzu Kubernetes Grid is, again, the second layer, and I've said it's more focused on the open source. The way that you can gain consistency across different infrastructure providers is just by abstracting and align with the community and open source. The way that I'm monitoring or getting logs from a Kubernetes cluster on vSphere should be the same as I'm getting that from an AWS cluster, an Azure server, or an Azure cluster, or a GCP cluster. Same goes not just for monitoring, but identity management, of course, cluster lifecycle management, and ingress controllers, and everything else. And to be able to do that, I need to abstract myself from any vendor. And the way to do that, again, is open source. So you can leverage open source capabilities from the CNI, from the load balancing, ingress controllers, image registry, monitoring and logging solutions, and identity and management across all of those different infrastructure providers supported as part of Tanzu Kubernetes Grid inside that same package. So it will allow you, like I'm getting back into the first drawing or the first slide, you have those two different sides of the coin. The VI admin can create everything in vCenter, manage everything with VROps, vRealize login site, VRA, everything else, all the VMware stack. And then the DevOps engineer can leverage their own tool sets in VMware and not on VMware and get that consistency across any Kubernetes cluster. So answering those two different challenges, answering those two different consumers and customers internally. Last but not least, the Tanzu Mission Control. So Tanzu Mission Control, as I said, is basically the management abstraction across different control planes. You have different local control planes. One of them can be on vSphere, one of them can be on AWS, one of them can be on Azure. And I want to have that consistency from one dashboard. Create clusters, lifecycle manage those clusters, and then enable lots of different capabilities regardless of the lifecycle management, like identity management, policy, security management, data protection, integrations to other services like observability or Tanzu Service Mesh, connecting to just understanding configuration drift, audit and conformancy tests, and a lot of other capabilities, but across any Kubernetes cluster. So you can see three different control planes where I can actually create my cluster, provision them, and manage the lifecycle management of them. But you can see in gray a lot of other Kubernetes clusters. Those clusters still can be managed by Tanzu Mission Control by attaching them into the control plane. It's not like I'm provisioning those clusters and managing the lifecycle management of those clusters, but I'm still managing those in any other aspect. And there's a lot of different capabilities, as I said, and to be able to enable on those clusters and still get that consistency across basically any conformant Kubernetes cluster. So you can see Google GKE, DIY, EKS, and OpenShift. Of course, AKS is here as well, Rancher, and anything else that is conformant. I'm saying a lot conformant, but what does that mean? So conformancy is being checked by the community with 275 parameters that you basically need to be aligned to. And those parameters is being basically described by the different SIGs. SIG is a special interest group inside the Kubernetes project. So each SIG, SIG for storage, SIG for network, SIG for apps, and so on and so forth, is creating their own best practice conformancy parameters. And then you can run your cluster and understand if it's conformant or not. To get that abstraction and the ability to move and transition between different clusters, you have to be conformant. If you're not conformant, it's not gonna be seamlessly between the different clusters. I'm gonna pause for a second before I'm heading to the demo. And if anyone has questions, now is the time. I don't see any more questions, but I'm not with Q&A open. Yeah, okay.
No, we don't seem to have any questions at the moment.
No, I think I'm gonna keep going, and if there's any questions, please just put it on the chat or the Q&A. So two more integration points you have to Tanzu Mission Control to basically create that management experience. One of them is Tanzu Observability, and that's basically a cloud service that will allow you to integrate 200 and some integration points to application, microservices, platforms, infrastructure, IoT, and others, and basically aggregate everything like matrix, traces, histograms, or span logs, and then create either actions or create dashboards for that. And the value proposition of that layer of Tanzu Observability is the amount of event per second you can actually digest in that. Most of our customers are customers that was born to the cloud, and they have a huge amount of workloads running on microservices being monitored by that dashboard. I will show that integration point inside in the demo for a couple of seconds. The second integration point for Tanzu Mission Control is Tanzu Service Mesh. Tanzu Service Mesh will allow you to get a centralized mesh management where you are connecting everything between the dots across different Kubernetes clusters and outside of the Kubernetes cluster in layer 7 management control plane. Now that's a little bit complex, but basically what we are creating is a layer 7 network layer that allows you to have a DNS, a root CA, encryption and security, observability, and actionable items like apply policy on security context, or apply SLO policies for application, or deploy and upgrade your application in a progressive way, basically connecting the dots between different open source, different Kubernetes clusters and different objects outside of Kubernetes, like VMs or services or cloud services and others, and to the same mesh and to the same connectivity layer. Yeah, okay, so let's go to the demo. Before that, can we provision TKJ workload cluster in different VMware environment using supervisor clusters sitting in different VMware environment? Absolutely, yes. So I will show in my demo that I'm connected to different vCenters with my Tanzu mission control, and I'm provisioning clusters to 2 different vCenters, including not just vCenters. So I can provision either to different vCenters or to AWS or to Azure or to basically any integration point or infrastructure provider that I'm exposed inside my Tanzu mission control. And it's definitely something we can do, yeah. Okay, so let's start with the demo. And again, if there's any questions, please just put it in. I will try to address them while it's getting in. So what you see on the left side is my vCenter. What you see on the right side is my console. And I'm using the console to basically interact with my Kubernetes cluster with API calls, but I can also use a UI. So we have Octant. Octant is an open source developer UI that basically does that kube control API calls and expose that in a cool, nice way. So I'm interacting right now with my 12, 15, 116, 1 cluster, and that's my supervisor cluster. If I will go inside the Octant and I will go to nodes, because I want to show you the nodes, you will see the nodes are the ESXi themselves. That's the agents or the nodes, the worker nodes. And you can see 3 VMs running as the control plane. So that's a cluster that is onboarded and enabled with Kubernetes, with NSX and Kubernetes. And you can see that NSX is the CNI for that cluster. From a different perspective, if I will take a different, that's the cluster itself. So you can see those the 3 VMs and those the ESXi's that are agents. In a different data center, I have a different vCenter that has, again, Kubernetes enabled, but here it's being managed by AJ proxy. And that cluster is built on different, let me just change the context. So we use just a second. Come on. Now is the time for network connectivity issues. Okay, just a sec, I will connect again. I'm sorry for that. That's one of the challenges that coronavirus brought our life, working from home and broadcasting from home. So yeah, it is what it is. I'm sorry, just a sec. Okay, so I'm back connected into my console, and I'm gonna change my context to my second Kubernetes cluster, and that's the second supervisor cluster that's in the second control plane or the second vCenter. And if I will get nodes here, you will see the nodes in that cluster is just the VMs. So you don't see the ESXi's. Those are the 4 ESXi's in that cluster. You don't see that. It's just the VMs themselves. So just those 3 control planes. That a cluster will allow me to provision clusters, like you see here, vSphere Alchemy cluster 1, and in main Tanzu I have a different cluster, but I can't run workloads directly on that. So most of the demo will be on that cluster where I have NSX and I can actually run workloads, just to show you how it looks like when I'm running pods directly on vSphere. Those 2 different vCenters, by the way, is enabled in my Tanzu mission control environment. So I can provision cluster on each of them, regardless of NSX is existed or not, because Tanzu mission control is just creating additional Kubernetes cluster or TKG cluster on vSphere itself. Okay, so let me go back and use my vCenter and vCenter with NSX, and that's that's the cluster that I'm showing you right now. The first thing we're going to do is basically we're going to create a namespace. So I'm going to right click on the cluster and I'm going to do new namespace. That will open up the option of creating new namespace, if the networking will allow me to do that. So I'm going to call that demo, and I'm going to create that. That will transition me into a window where I can actually now create that playground I've said I can do to my developers. So the first thing is I can basically expose to my developers that UI, and that UI will allow me to download the CLI that I need, the plugins that I need to interact with kube-control with my vSphere environment. So basically, when I'm exposing that to my developers, I will send them that link, and they can take it from here. So they will have the kube-control API, the kube-control vSphere for login, and according to the permissions that I will add here, and let's add permissions from my SSO domain, let's say DevOps user. So if I'm giving my DevOps user an edit permissions, and I'm sending him that link to this URL, he can now basically interact with that namespace and do whatever he wants. He can create clusters, objects, or any other thing. And if those developers needs, or DevOps engineers, or the application itself needs persistency, I have to bond that namespace into a storage. So when I'm clicking on storage, I can see my storage policies. I'm clicking on the one that I want to basically assign. That's assigned into a data store. As I said, that data store doesn't have to be vSun. Any data store that will be mounted into the vCenter will be managed and enabled. I can create capacity and usage quotas, so basically quota policies. And you can see Tanzu Kubernetes clusters. There's no cluster running right now. The first thing that I'm going to do is I'm going to use Octant, and that's my developer UI, to basically deploy an application. And that application will be just a simple application running just an Nginx application directly on my ESXi. So without NSX, I wouldn't have that capability. I'm going to change my namespace into demo because I want to deploy that on demo. And I'm going to do apply YAML file. That declaration file is now saying to Kubernetes, what do I want to run? So I want to run Nginx, that's just a web server, with 2 replicas. So it's going to create 2 different pods or 2 different containers. It's going to pull the image, the container image, from my Harbo. I've said about Arbor in the presentation. Harbo is our registry of choice. It's open source. We've contributed that totally to the Cloud Native Computing Foundation, and I'm using that as my registry. And I'm also creating a service for the networking stack with a load balancer state. So I'm going to do apply. Let's see if it's got in. If not, I think that I need to basically create a different session. Let's see, demo. No. So let's do that with the command line. I think Octant just lost connection because of the thing that you saw at first. So what I'm going to do now is I'm going to do that directly from the CLI with a kube-control API command. And let me get into my folder first. Home, local, Tanzu demos, yeah. And the YAML file that we will deploy is exactly the same that I showed you in the browser. So that's the YAML file, still pulling from Harbo and service load balancer. And we're going to do a k create -f nginx in the namespace demo. So that it's going to create my deployment, and it's going to create my service. And you can see on the left side, the Nginx deployment is being created. If I will open up the task, you will see those 2 pods being created. Now that's a Kubernetes pod running directly on ESXi. So if I will click on one of the pods, you will see it's running on ESX03. So it's just like running on bare metal, right? It's running directly on the ESXi as the OS itself. If I will hover about the namespace, I can now see a lot of different Kubernetes events and objects directly on my vCenter. So I can go to monitor and see Kubernetes events. I can go to compute and see my pods. If I will click on the YAML file, I can actually see the object that is being run right now on the Kubernetes side. Same goes for deployment. And same goes for deployments. So I can click on the deployment and see the desired state and the run state. So it's 2 out of 2. So it's fine. Everything is working. And I know that I've requested for a network. So I can go to services and see my networking service. That's a load balancer. So NSX assigned me an IP that I can actually browse. If I will take that IP and I will browse that, there you go. That's my Nginx. So that's my application running directly on the vSphere environment. Now, I didn't use anything else, but if I would request it for persistency, the storage of the Kubernetes storage policy was basically bound into that persistent volume claim, and I would see that directly reflected in my vCenter. The second step is to create a cluster. So if I want to create a cluster, I can basically do the same thing. So I can take my YAML file and just run that from the API, so just from the console, basically stating that I want a dev cluster 1, one control plane, and one worker, and that's the version. Now, the question that I'm getting a lot is, how do I know what's the version? It's not like a container image that is in a registry. That version is basically stating a VM or an OVF that I need to basically create a Kubernetes cluster from. And that's part of our content library structure. So if I will go to my content library in my vCenter, you will see a new content library of Kubernetes. That content library has OVF files that basically represents the versions of Kubernetes you can utilize and you can use and you can provision. Now, the second question I'm getting is, can I change that because it's Futon OS? The answer is Futon OS is supported from the OS app. If you want to change that, you can. You can bring your own image. You can use other OSs as long as you're supporting the OS. VMware will support you totally from the OS app if it's Futon. If it's not Futon, we will support you from the Kubernetes app. So we can support you on the OS itself, but it is possible to bring your own image and just change the version into whatever you want. So instead of doing that from here, instead of basically creating that cluster with an API call with a console, I'm going to do that from Tanzu Mission Control. And I'm going to open up my Tanzu Mission Control window. That's my Tanzu Mission Control. The first thing you can see is that I'm managing a lot of different clusters. I'm managing AWS clusters, Azure clusters, and Google Cloud clusters. You can see also vSphere clusters. And you can see that, by the way, those different clusters are in different vCenters. So the management cluster is the supervisor cluster I'm interacting with. One of them is vSphere PES Dev, and the other ones is vSphere AJS main supervisor. So that's the question about the two different data centers or two different vCenters. When I'm getting into administration and I have management clusters, I can basically add management clusters, either AWS or a vSphere, as much as I want. I can do more than just two. In this case, I have two. One of them is in my the environment that you saw without NSX, and one of them is with NSX in a different data center. So going back to cluster, the first thing I want to show you is how to provision a cluster. So I can create a cluster, and now I'm being asked, where do you want to provision that cluster? On AWS or on vSphere? Now, because we are in a vSphere presentation and that session is on Tanzu Run, I will do that on vSphere. So I'm choosing vSphere 7, and now I need to choose which management cluster I want to provision on. In this case, I'm going to run that on vSphere AJS main soup. So to do that, let me open up just my vCenter. In the meantime, and the provisioner will be the namespace that I want to deploy the cluster on. So in this vCenter, I have two different namespaces. One of them will be main Tanzu, and the other one will be dev. And thank you, Daniela. And what we're gonna do is we're gonna deploy to main Tanzu, and there's already a cluster on that namespace with the name main Tanzu 1. So we're gonna just create main Tanzu 2. Now, another thing that I didn't show you in the environment with the NSX internally is that when you hover above that namespace, it's not just Kubernetes objects you can see. So when I'm hovering above, let's say, the main Tanzu namespace, when I'm going to compute, there's no Kubernetes objects here, but there is Tanzu Kubernetes objects, and that's the cluster itself. So the cluster is being declared just like you saw in the YAML file, as part of a declaration file in Kubernetes, And you can see that as object running inside my namespace. And I can also see virtual machines running as objects inside my namespace. So basically, I'm going to deploy to main Tanzu at the second cluster, so main Tanzu cluster 2. Let's go back to Tanzu Mission Control. Next, and now I need to give it a name, main Tanzu cluster 2. And cluster group will be the group that you want to basically attach the cluster to. And by attaching that cluster to a group, you basically can apply policies of identity, data protection, security, and other policies. In this case, it's part of my vSphere clusters. So it's a vSphere cluster. It's going to be attached into that. And I can do next. Here you can see now the same exact YAML file formation, but in a wizard. So I can decide which kind of OVF I want to utilize. In this case, I want to utilize the latest one. So it's 118.5. What's the pod sider and the service sider? And that's an internal IP stack. So I don't really need to change that unless you have some conflicts in your environment. The IP for the load balancer to the control plane of that cluster will be assigned by AJ proxy in my case, because that cluster is being managed with network of AJ proxy, not NSX. If I had NSX, NSX would assign to me that load balancer for the control planes. Either way, I'm being taken care of by the foundation itself. And if it was AWS, I would have been assigned with Elastic Load Balancer, ELB of AWS. So it's exactly the same. If you think about it, the foundation in vSphere, it's like the local hyperscaler. It's taking care of everything you need when you need that on the Kubernetes layer. So I need to choose basically the storage class. That's the data store that the VMs will be provisioned on. In this case, I've attached my Kubernetes storage policy into the namespace. So that's why it's visible here. Can do next. And now I'm saying how many control planes and how many workers do I want. In this case, I don't need high availability. So I'm going to stay with single node. Now I can also change the form or the size of that VM. In this case, I can do that large, and I can do just next. In node pools, I will decide how many workers will I have. So in this case, I have only one. And again, I can change that into large, and that's it. Once I'm doing create cluster, that API call of kubectl apply -f with a YAML file is being applied on my supervisor cluster. So if I will go to main Tanzu, you can already see main Tanzu cluster 2. You can see it's being created, and you can already see deploy OVF package. So deploy OVF package is basically cloning a VM and creating that cluster for me according to the manifest that I've created in the in Tanzu Mission Control. Now, same goes not just for the creation of a cluster. So I've created that and it's being created. But if I will get into a cluster that is already being created, that's the main Tanzu cluster 1, I can go into node pools and say, you know what? I don't need 3 nodes. Do that too. Save. That will go and now shut down one of those workers and reduce the number of that number of workers. Now, it's not just resizing, it's also reducing. And in the same way, you can also upgrade the cluster. So if you will go to a cluster where you have capability to upgrade that, and you can see that by the bubble, and that, in this case, that's even deployed on AWS. It's not even deployed on vSphere. If I will click on that and I will go to Actions Upgrade, you will see the version that you can upgrade to. And by choosing that and doing upgrade, it will do a canary upgrade with 0 downtime. So you can totally manage the lifecycle management of the clusters directly from your Tanzu Mission Control. Now, that was just lifecycle management. Everything else inside Tanzu Mission Control, like identity management, security and policy management, inspections, backup and restore, integrations, everything else can be applied on any conformant Kubernetes cluster. You can see I'm managing here Azure clusters, so AKS. I'm managing GKE clusters. I'm managing DIY clusters that I've installed. So basically, I can attach any cluster that I want. And the attachment is just by create attach cluster, created a name, let's say test, choose a cluster group, let's say test cluster group, and apply that command line. So kubectl apply and that YAML file. That will install all the things you need inside your cluster and basically take ownership on that from a consistent of management and security. Now, of course, I don't have a cluster right now to deploy, so I'm going to leave it like that. We can detach that. So just let me detach that so I won't have that in my console. But basically, the attachment is just applying that command line. So one thing I can show you from security perspective, because we don't have the time, is I'm going to use I'm going to change my context into my Tanzu cluster 1. Main Tanzu cluster 1. And now I'm in my vSphere cluster. That is the main Tanzu cluster 1. And you can see a namespace called Nginx. That Nginx namespace is being created by Tanzu Mission Control. So we have a structure called workspace, and that will allow you to basically create and aggregate multiple namespaces on multiple clusters, and then apply policies on that structure, not just on a Kubernetes clusters group, but also on a namespace cluster group. So what I've created here basically is I've created an Nginx namespace on that cluster. So if I will try and delete that, by the way, delete namespace Nginx, that won't work. Like anything else in Kubernetes, if it's not running against the intended state, it will reconcile. So I've deleted my Nginx namespace. Kubernetes will understand there's no namespace. And if I will get namespaces again, you will see it's up for 2 seconds. Same goes for policies, security aspects, and everything else. Kubernetes will always make sure you're running against the configuration that you've created. So in this case, what I did is I've applied policies on that namespace. And one of the policies that I've applied on a workspace construct is I've said in image registry, you have to pull images from Harbor. You remember I've said that I have an Harbor, that's an internal registry. I don't want to pull from Docker.io. I don't know if there's vulnerabilities or not. I just don't want to do that. So if I will try to run Nginx, and I will try to pull the image directly from Docker.io, and I will try to run that on the namespace Nginx, I will get an error saying, you can't do that. It's forbidden. You're violating a policy. If I will do exactly the same command, but instead of pulling from Docker.io, I will write harbor.tanzuworld.com /opensource/nginx. Yeah, typo. Tanzu world. Come on, where's the typo? Harbor.tanzu. There you go, it's not com. There you go. The pod is being now created. So I didn't get that error message. And if I will get pods in the namespace Nginx, I will see the pod is running. So that's an example of security aspects that you can get consistency across any cluster. And another example that I can do in the next 2 minutes that I've left, another value proposition of that Tanzu Mission Control is the operational pain you're getting. So allocated CPU, allocated memory, components health of the Kubernetes, nodes health, Kubernetes and Tanzu Mission Control health state. And you can create backups in data protection, and you can do inspections. So in this case, this cluster didn't went over the CIS benchmark, but it did went over the conformancy benchmark. So if I will go to inspections, I will see my cluster success result for conformance. If I will click on that, I will see the 275 parameters that I've said to you that is a conformance test. And if I will go to inspections again and CIS, you will see there's 11 parameters I need to change to align with that regulations. In the backup mechanism or the data protection, if I will click on create a backup, I can decide if I want to create backup for the entire cluster and namespace or according to label selector. I can do that scheduled or right now. What's the retention weight and what's the name? That's it. That will basically back up my cluster. And then in the data protection, I will see all the backups and I can click on one and restore. And that will allow you to basically get consistency for data protection across any conformant Kubernetes cluster. There's a lot to see and there's a lot more to show, but we don't have the time for today. I hope the session was useful for everybody. And if there's any questions, I'm available for questions right now. what would be the main driver to go NSX? Just wondering if there's a limits not using, yeah, so NSX, as I said, the limitation without NSX is not running native pods. That's the main limitation. NSX is the main cloud network interface for the supervisor cluster. If you don't have NSX, you don't have CNI. And if you don't have CNI, you can't run workloads. So if you want to leverage supervisor capabilities, and there's a lot in them, like value for performance, security isolations, services that will be enabled directly on vCenter. We are enabling you to basically in one checkbox, enable data services or registry services, and they will run on the Kubernetes side of the supervisor, but they need networking. So you need NSX for that. Regardless of Kubernetes, NSX is the most robust programmable network there is right now in that cloud native landscape. So it's not just the supervisor cluster. Security aspects, microsegmentation, IPS, IDS, a lot of additional values. But again, that's a different session with a different deep dive on NSX. Are there any VCF sessions? I don't know, Daniela.
Yeah, hi. Actually, thank you for your question, Senthil Kumar. Apologies if I'm not pronouncing it the right way. Actually, we do have a session on Thursday on day 2 processes, VMware Cloud Foundation. So make sure to register. It's at 9:30 a.m. PST. So make sure to bookmark the Connect Learning website. You will be able to see the upcoming webinars as well. We're preparing a lot of great content for all of you next year. We don't seem to have any further questions, right, Oren? Yeah.
Okay. I think we are in the top of the hour. So yeah, it's okay. I hope it was useful for everybody.
Yeah, thank you so much, Oren. You were great. And thank you everyone for your active participation and for joining our event. Have a great day and make sure to click our playback next week. Bye everyone. Thank you.
Cheers. Bye-bye.